This video is brought to you by Greater Commons. Greater learning, greater opportunities, greater life. Visit us at greatercommons.com.
All right, so now we're going to create a little function. So just get rid of this stuff. Get rid of this. And so I'm going to create a function, and it's func, and then a receiver. We don't know what those are yet, but eventually we will. If I had one, it'd be here. And then identifier. I'm going to call this foo, and then parameters. It's going to take in a string, and it's going to return a string. And so I'm going to return hello. And so it's going to concatenate. I pass in a string. It's going to take that string and concatenate it with hello and an exclamation point. If I wanted to, I could do this. So now I will come up here and I will say that this returns a string, so I'll say, just s : equals and foo, and I'm passing a string in, so I want to put in double quotes. Question, what could I use other than double quotes? What character? What lexical mark? We talked about it. It's backtick. So I can use a backtick or double quotes to signify a string. A backtick is a raw string literal. And that means I could have double quotes in here if I wanted, and I could pass those in. I'm going to format this and run it. And s declared and not used. Funct print line s. Hello, Mr. Bond. I've been awaiting your arrival. And I'm copying all these, so I'm getting the share, and I'm putting them into our course notes for tonight. So func concat. Okay? So there are all these funcs that I'm creating. You'll be able to click those links and come straight back to the code. So if you're like, oh, how did he do that one with the func and the return? You guys will have all that code. And I don't know what this one is. I didn't label it. This is just a basic func. Wow, that's big. I'm not typing anything there.
Really, really important.
Func. Putting it on that side for that one. All right, so that's func string concatenation. So I just want to review what you've learned so far tonight. You've learned variable declaration. What do you know about variable declaration? Everybody think about it for a second. Nobody answer? What did you learn about variable declaration?
Do we answer now?
Okay, answer.
Okay. It establishes what the variable is.
Assigns a value to an identifier. That's perfect, and I'm also just giving you words to learn the language that we use to talk about programming. Assigns a value to identifier. Okay, variables store values. That's it. It's not complicated. Variables store values. And we assign a value to an identifier, and that value is of a certain what? Type, right? And we also learned what about variables? How do we do it? What lexical element? What lexical element? Lexical elements. So lexical elements are like Here's a lexical element. What does that lexical element do? Lexical, lexicon, relates to language.
It specifically declares the variable.
Short declaration operator allows us to just say, hey, this identifier, this variable, we're assigning this value to it, and it figures out the type. And we could only use the short declaration operator in certain places. What are those places? Where can we use the short declaration operator?
Within a function?
Within a code block, yeah, which is basically a function. I'm not perfect with all this stuff. I studied economics and business, so there's always part of me that's like, is there another code block that's outside of a function? I can't think of one right now.
Sometimes the terminology it's like you speak in Latin.
You could declare a variable outside of code block to make it universal.
But we can't do it with the short declaration operator. And it's not universal, it's package scope. It's package scope. Okay? That's great. You've learned some good things about variables. And then we went on and we learned about funcs. Okay, so I want you to all think about it. Don't answer yet. What is the general syntax for a function?
Function, receiver, identifier,
In return.
parameters, and returns.
Parameters and returns. So function, receiver, identifier, parameters, returns, and then code block.
When you identify those, apparently everything but the identifier is optional. But would the syntax for that be function and then any possible receivers are parenthetical, and then the identifier is out of that, next part is parenthetical, and then so you just alternate? Okay.
Yeah, so at a minimum for your function, you need this. Okay?
And that empty parentheses just declares there's no necessary parameters or returns.
Yeah, no parameters defined, and you always need that. That's a minimum. And when you call a function, you always have to call it, right? As if you're saying I'm not passing in anything, or if I was passing in something, all right, that'd be like the next thing. I'm saying here's the parameter. Now I'm passing in an argument, and I might have that just. And then if I wanted to, I could have a return. I could have return, so I could just return a string. But now I need to assign that to something over here, right? And I could do funct println s. Or variable substitution, s is equal to that value. And now I'm saying put that value here, right? I could just do this. And that could be a little bit weird for people when they're first getting into programming. They're like, what is going on there? I was following you until you got to that. Now that just looks like weirdness. Right? How many people that looks weird? Like, whoa, that looks a little crazy. Because all I had before, s colon equal, right? What is s? S is that value. So I had that, right? That's the same thing. It's saying put that value there. All right, I'm going to put that value there and just skip that step. So you read it from the inside out. So the function foo runs and it's passing in the argument bond, which is a string. And then that returns a string, and then we print it. So you can nest function calls like that. It's kind of cool.
Would you do something like that if you just wanted less code to go over or something? You just wanted less lines?
As you become more fluent in a language, you learn the abbreviated patterns for speaking the language,
Oh, okay.
right? And yeah, so
Yeah.
what you said, man,
Make
less
it
code,
work. Yeah. Okay.
right? But, you know, I'm just trying to draw an analogy between programming and a normal language, because in a normal language, we might, when we first learn the language, like, yo me amo Todd. And then you say that to somebody who speaks Spanish is like, no, 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 me amo Todd, right? Oh, you drop the yo.
Yeah.
Oh, okay, I dropped the yo. And you learn the short, abbreviated ways of speaking the language.
It still sends the same message.
Since same thing gets done. Not a perfect one-to-one analogy, but. All right, so we learned funcs. Then we saw how to pass arguments to funcs, and we saw how to do returns with funcs. And we saw how to do string concatenation, which is kind of cool. And now we're going to learn about some data structures. And we're going to learn about 3 data structures. So everybody focus in, Jedi mind. So there's 3 data structures. A slice will keep a list of values of the same type. In some programming languages like Python, they actually call it a list. And so that would be var xs. I'm just giving that identifier. It's a variable. Xs is a slice of string. So that would be a slice of string. And I'm giving it package level scope, so it's not going. I could access this in either function, right? And so I could do. Just thinking about how to do this. I could do. And you know, I'm gonna just teach you the composite literal way to do it. Let me undo that. All right, so colon equals, and it's going to be a slice of string and curly braces. So composite literal. Composite literals. Let me see what the language spec says. Composite literals construct values for structs, arrays, slices, and maps. Okay? What's a composite literal? They consist of the type of the literal followed by a brace-bound list of elements. Okay? So here is the type. It's a slice of string followed by a brace-bound list of elements. And I'm just going to put them in. Bond, money penny, Q. What's the woman who runs it? She's like M. I think they like the Go programming language. They have all these short names. You're supposed to use short variable declaration, short variable identifiers. And that's a slice of stuff. Bond, moneypenny, Q, M. Pretty sweet, right? And I could access that by index position. because it's like a slice. It's like an array in other languages. And I could do XS. What's in position 0? So it's a 0-based index. Bond. What's in position 2? Who could tell me? If bond is in 0, what's in 2?
Q.
Q. Right? 0, 1, 2. I could actually iterate loop. You can use either word over a slice with for range. So for index value colon equals range XS funct print line in index value. So it printed out 0, position 0, bond, position, index position 1, money penny, and index position 2, Q, index position 3, M. I could also find out the length of the slice. Calling a function. It's from package built-in, I think. It's built into the language. There's length. Func length. And I also have cap. But there's the length of the slice. The length is 4. So I'm going to do this and call it slice. And that goes here. And I need a new bullet. And I don't need a bullet, and these need to come down to like 14 or something. I need a bullet. There we go. And slice. And I think these are 12. So make these 12. So that's a slice. Let me give you the whole kit and caboodle. All right? So the thing you want to brand into your head is when I need a list of values of the same type, it's a slice. Now we're going to learn about a map. A map stores key value pairs. Key value pairs are huge in programming. And they're really fast for looking things up. And so again, I'm going to use a composite literal. And I'm going to say map string int. And I'll call it just M for map. I call this XS because X is a slice, right? Those two things are crossed, and it was a slice of string before. I called it XS. Now I'm calling this a map. I'm just going to take this out. Well, I'll leave it, I guess. And all right, I'll just change as we go. Don't look at the stuff down here for a second. So just look up here, all right? So now we have a map, stores key value. This is how you do a composite literal for a map. It's the literal type, the type, in curly braces, and the values. So now you need to store some values. So a string and an int. If you're ever wondering, how do I do that? There's a nice example, Go by Example, this website, Go by Example. And you can look, how do I do a map? See, we just learned about a slice. Here's a map. Here are variables. So let's look at map. So map would be, doing it that way. Print line map, M, the whole map. Value 1, I'm trying to remember how to do it myself. There we go, right here. So here's the composite literal. Foo1, bar 2, so I could just take those. Or to stick with the theme, Bond. He's like probably 32. Moneypenny. She's probably like 24. And Q is probably like 65. And M, she's probably like 58. I don't know. And then let me get rid of all that actually now. There are all my values. And they're always going to come out in a crazy order. Though Golang Playground keeps it the same. But you can't rely on the order of a map. You can rely on the order of a slice, not on a map. So now I could pull out values. So access by key the value, map, and the key is Bond. So Bond's value is 32. And iterate over a map with a for range. These could be called anything. They could for the slice. They could for the map. For slice, I call them index and value. For a map, I call it key and value. But they could be called anything. So key and value. And now iterate it over them all. And now let's find the length of the map. Not always sure if you could do this stuff. Yeah, cool, length of map. So this is a map. Okay. So we have a slice. We have a map. And if we look at the effective Golang spec, up at the index, you see we've learned about slice types. We've learned about the map type. We've learned about functions. We've learned about string, numeric, and bool. A little bit about bool. Last thing's like a struct. I'll do struct for you in the next video. Let's take 5 minutes and let me pick out an assignment for you.